Welcome to this demonstration of the DeviceLock DLP suite. When you install DeviceLock, you get three different consoles on your server desktop: the Enterprise Manager, the DeviceLock Management Console, and the Service Settings Editor. You also get a snap-in to the Group Policy Management Console. The server component is not administrative in the sense that it is just used to collect audit and shadow records from the endpoints, the only exception to that being if you use it to help manage a Macintosh through group policy. When you look into the Enterprise Manager console, you're able to see your entire environment a number of different ways: OUs, computers, LDAP, or even load a file in. From here you can see your machines. You can install the service, an MSI 32 or 64-bit, that's pushed out to the endpoint, much like an antivirus agent. Once you do that, you then would be able to push settings with this console to that endpoint. If you choose to use, say, group policy or SMS or another tool to push the MSI to the endpoint, then you can configure your settings right inside of the Group Policy Management Editor. Here you'll see that you have the same settings we'll see in the consoles later on. You'd be able to load your settings in, export your settings out, just like you would in the other consoles. So it makes it very easy to ensure that all of your machines in an OU have the correct DeviceLock settings. You can even use a software installation GPO to push out the DeviceLock MSI. When you open up the DeviceLock Management Console, you can connect to a single endpoint. In this case, we're connected to our Windows 7 machine, and you would see all those same settings we saw in the Group Policy Management Console. You also have our Enterprise Server controls here. This is where you would see the audit logs that have been rolled up into a SQL database. It can be a SQL Express database or a full SQL server. The shadow logs, where we can actually collect the data that's moved to any particular channel that we control. That would be things like files copied to a thumb drive, emails, clipboard, for example. There's monitoring tasks in here where we can scan your environment, report on which machines have the service running, as well as verify the service settings file, or even deploy the DeviceLock service, as well as some reporting we'll look at a little bit later on. And then at the bottom of this is our content security server. Here you have the ability to search the information that's in the audit logs, as well as an index of the content in the shadow files. And then at the bottom here is our separate discovery server. This is the data at rest piece. This tool can scan machines in your environment, as well as file shares for data that you define and report back, as well as remediate. So it could delete that data, it could change permissions on it, it could encrypt with EFS, log, alert, etc. When you get into the configuration, you start under Service Options. Here you're going to see a number of different things. This would be where the pop-up messaging is, so the end users know why they've been blocked, fully configurable with global variables. You also would see a number of different messages that could be popped up for different reasons, whether it be content rule violations, protocol violations. So it gives you quite a bit of flexibility in your messaging to the user. In this list, you also can define your enterprise server. This is so the endpoints know where to ping up to get their data collected for logging and shadowing purposes. We use RPC6 for that. The DeviceLock certificate, a certificate pair that improves the authentication between the endpoint and the server, is defined here as well. And then our online and offline detection mode is set here. DeviceLock supports both an online and offline configuration. So if you have machines that leave your environment, they can run a separate policy specific to being off the network, possibly more secure. Maybe you want to allow wireless when they're off the network, but block wireless when they're on the network, or other examples like that. You can make that determination of on versus offline by their ability to see the DeviceLock Enterprise server. If they're running on cached AD credentials, that would be domain connectivity, or wired versus wireless. Also in here, DeviceLock administrators. This tool lets you control who has access to the consoles, as well as locks down the endpoints so that even local administrators can't stop the DeviceLock service, uninstall it, or make any changes to the registry or file system which would affect DeviceLock. It's a very powerful control. It even prevents people from getting around the product in safe mode. But one important thing to note is that if you do enable DeviceLock administrators, you will have to turn it off if you use third-party tools like SCCM to deploy the latest MSIs to your endpoints, because it would prevent those from installing. Some high-level auditing and shadowing controls here, audit log types and quotas. Alerting, we do alerting directly from the endpoint, SNMP and SMTP alerting. This is real-time alerting, so it does come directly from the endpoint. They need the ability to reach both of the SNMP and or SMTP servers. Anti-keylogger functionality. This would be the ability to detect hardware-based USB keyloggers. If we see anything we suspect might be a keylogger, we can block it, the keyboard, we can log, we can notify. We also support PS2 keyboard scrambling. Finally, in this list, you see our encryption. This is the encryption types that we recognize. We don't actually do encryption. We've chosen to go down the path of supporting a number of software encryption types, things like SafeDisk, TrueCrypt, BitLocker to Go, or even OSX File Vault. And later on, you'll see that we can have separate policies. So if we detect an encrypted device, you may be able to want to allow someone to write to that device. If it's not encrypted, it could be a read-only device. If you use a hardware encrypted device like an Iron Key, Apricorn drive, or something like that, we can handle it in a similar fashion with our USB devices whitelist. When we get into the USB port or the devices configuration, this would be the core DeviceLock module. We start at security settings. Here you'll see that we have our controls for USB HID. We disable our control of that. We want to make sure your single function mice and keyboards function. If you do not configure offline, it will inherit your regular permissions. You can also make some other high-level decisions here. Do you want to have to whitelist the USB printers in your environment, or you just want to let them work? Same type of thing for USB FireWire network cards, or even with Bluetooth. You can block Bluetooth, but then allow single function mice and keyboards to function over the Bluetooth HID protocol. Here we've enabled our control for USB storage devices. Once we do that, we go to permissions, and here you'll see all the channels that we control as part of the core DeviceLock module. This would be a number of things that run below the USB port, as well as things that are at the same layer. You'd see things like Blackberries, Bluetooth control, even clipboard control. Very granular, not just on and off, but control that is based on content of what you're putting on the clipboard, as well as screenshots and third-party screenshot control. We work with a least privileged approach. So if I remove the everyone group and administrators, we would be taking away access for people. That works very well, just like Windows permissions. We want to avoid an explicit deny where possible. That way you can always give permissions back where needed. All of these controls have day of week and time of day controls as well. Coming down the list here, you'll see things like FireWire port, floppy drive, iPhone. With the iPhone, this controls Apple's integration with our how Apple can integrate with the iTunes APIs, so we can prevent an iOS device from syncing over USB on certain channels like read calendar or write email, or even allowing or backups to happen. MTP. This is a lot of the new multimedia protocol devices, things like Android phones, even new iPhones can connect to this, as well as cameras. Read and write control for optical drives. See, we have parallel port for a lot of the legacy ports that you might see on a laptop dock, or even some of the older equipment in your environment. Serial ports as well. We get down to TS devices. This would be our controls in a Citrix, XenApp, XenDesktop, VMware View, Microsoft RDP environment. By installing our product up on the server, if someone remotes into that from an unmanaged endpoint, we can control their ability to use the clipboard into or out of that session. We also have the ability to control map drives, And if they're using a Zen desktop or VMware View environment, we can even use our USB whitelisting controls to limit what devices they can actually mount up to that session. When we get to the USB port, we control it 5 layers from the USB port all the way down to the unique identifier of USB device. Here you'll see that least privileged approach in action. I have my domain admins in, my system store drivers work. With just these two here, if you're not in this list, it's an implied deny. The only way around that would be getting added here or going into having your device whitelisted for a user group that you're a member of. From there, we go to removable and see that we still have that same domain admins and system. We also have our demo user in here. Again, this user wouldn't come into play unless they had access at the port level or the device was whitelisted for them. When we go to our Windows 7 endpoint, if we connect a device logged in as that demo user that we shouldn't be using, let's mount that. You'll see that it attempts to mount the device, and once it realizes that we can't open it, you'll get your pop-up message. If we come back over to our logs, you're going to see in this list here, these are all the channels that we can audit, shadow, and alert on. And those are all independent controls. So we can do that separately from our control under permissions. I've already turned on a number of things for auditing and foreshadowing. So if we look at the log, you're going to see a few different things here. You'll see that failure up on top here where we had connected the USB device. You'll see the device that we connected. If we scroll to the right, you'll even see the processes that attempted to use it. You'll see this local service as well as the demo user here. That would be right there. Scrolling to the right, you'll see the failures. Now if we come back over to permissions and we want to see, give that user access to a device, we could do that at the USB devices whitelist. Here you're going to see we have the ability to collect the information about the devices from the remote machine. So here you're seeing the currently connected devices on the remote Windows 7 machine. We can collect those into our USB devices database, just a flat file that we store with the consoles. And from there, we can then add it to the whitelist. Note that we can add devices both by model, the VID PID, as well as by a unique identifier. So you could associate a specific model of device to a user or group, or you could associate all the way down to a specific device. Once we have that, we then add a user or group, and then on the right here you will see the devices that have been associated with that user. So we scroll to the right here, you're going to see the device ID, and you will see the control as type. Control as type is important to understand. It determines how granular you want the product to be. If control as type is checked, we're going to continue to evaluate to see what permissions that user has on the device type level. This would be like, say, removable storage. If you uncheck control as type, we're just going to let the device work and not evaluate that. Scrolling to the right, you'll see that we do have the option of read-only. So if you did want to uncheck control as type, you could still make a device read-only, and we can still audit and shadow at that lower level. So it does give you very granular control here. When we hop out of this and come back to our Windows 7 machine, if we connect a device we are whitelisted for, you'll see that we have access. If we come back over to our logs and refresh, up on top here, you're going to see the success. To the right, you'll see we had success for that device because of the whitelist for my demo user. So that was the contextual control of giving people access to USB devices with the USB whitelist. The next step would be to apply a content filter to that using our content lock module. Here we have a number of options. We have file type detection, where we have thousands of different file types grouped together into logical groupings. This actually comes as part of the core module. So here, for instance, if you go to images, CAD, and drawings, you will see a list of all the different file extensions that we control. We actually look at the binary of the file, so you can't change the extension to get around these. And you can also build your own groupings based on these file types. Beyond that, we get into the content lock module. This would be keywords. So for a number of different industries, whether it be PCI or HIPAA, ICD-10, ICD-9 databases, we have a number of different keyword lists that you can use to start with. You can use them as is as well. Coming down from that, we go to pattern. Under pattern here, you're going to see everything from U.S. Social Security numbers to credit card numbers, anything you can define with a regular expression pattern. You can set greater than, less than, equal to, or between thresholds on that. You can even use our OCR engine on these, as well as the keywords that we looked at previously. 27 different languages, including a number of double byte languages, are here. So we can actually inspect an image file if someone were to scan a text document in. And then you can test right inside of here. So if I put in a valid social security number, it turns green. If it doesn't match, it remains red. It's also very easy to modify these or create your own. We display the regex right here, and you can validate your code as well. Once you've seen patterns, you can come down to our document properties. Document properties will let you look at the file name, modify dates, times, file sizes. Is it password protected? Can we not extract text from it? We can even look in the header of the document. So if you embed the word confidential, for instance, in one of your Office documents, we can look for that and control access based on that. And then we can take these different rules and bundle them together in compound or complex rules. So we could say that maybe we want to look for a medical record number and a disease name to try and prevent PHI data in a healthcare environment from getting out. You could also use these to look for maybe a specific executable that you want to allow run while blocking others, or any other combination of these rules that would help minimize false positives in your environment while still giving you the control that you need. You then apply these rules to a specific user or group. On the right here, you'll see that we have a control in place for removable, saying that if there's more than 2 social security numbers in a file being copied to removable, we're going to block it. This is also an opportunity to make a distinction between generic and encrypted. So once we come out of here, if we go back to our Windows 7 machine and we copy a file over that has 2 social security numbers, you're going to see it will copy and replace. And we should be able to open that file up right into Word without any problem. There it is. Now if we copy a file over that has more than 2, in this case 4, you're going to see it creates a placeholder for that file while it scans it in memory. When it realizes that that violates the content rules, you're going to see we get our pop-up and that file disappeared. If we take a file that is actually a JPEG, it's a screenshot of that, and we copy it over, you're going to see that we also will get that pop-up and that file will ultimately disappear. When we come back over to our logs and refresh, you're going to see a few things. You're going to see some successes on the 2. You're going to see the failure for the 4. And if we scroll to the right, you'll see the reason we failed, the user that did it, and you'll even see the process we were in, Explorer. Down below here, you'll see that we opened that 2 up in Word. If we go one step further, because I had shadowing turned on and look up on the enterprise server and refresh, you're going to see we shadowed those failures as well. So here we can open that file directly from the server, even though it wasn't copied to the thumb drive. We also have a forensic viewer that will let you view the full raw text of that file as well, so you can use it for forensic or evidentiary purposes. Above that, you'll see the failure on the 4. Same thing, we can double click on that, open that JPEG right up. Next, we'll take a look at our protocol section. Here you're going to see we have controls for things like file sharing services. This would be things like Dropbox, Amazon S3, Google Drive, iCloud. So we can block access to these and then use this to give access back where needed as a whitelist and still do content inspection. In addition to that, you're going to see we have controls for things like webmail, which would control these services, like Gmail, Hotmail, OWA, but still giving you that control so you can limit who can send messages within those services or even who they can send messages to. This control would also include OWA. And then social media is another good one. You'll see here all the different social media services that we control. Anything from Facebook to LinkedIn to MySpace to Twitter. With these, you could also block and then give back access as needed. So maybe you want to give your HR department access to LinkedIn, do some content inspection to make sure they're not sending out any prohibited information, but you can still give them access to do their recruiting work or whatnot. Hop out of this. Some of the other channels that we would control would be basic HTTP, HTTPS that aren't covered by these other channels. MAPI control. We can control email right inside of Outlook. If it fails to be sent because of a rule in place, it will remain right in the drafts folder. Skype control, very granular, not just on-off, but call control as well as message and file control with content inspection. SMTP control, we talked about social networks, Telnet, BitTorrent control, WhatsApp control as well, and then a number of other instant messengers in this list. I currently have AOL running here, and this is set up with that same social security number rule. So I have full access to webmail, but I have a content rule in place. So if I come in here and I put in too many social security numbers, we'll see what happens. You'll see we immediately get our pop-up. It failed to write. It never even leaves the machine. If I remove one of those, now we're compliant. I click send. And there would be our message. If we come back to our log, you're going to see a couple different things. Refresh. Here you'll see the failure on the outgoing message, who it was sent from and to, the subject of the message, and to the right you're going to see the rule that it violated, as well as the user that did it, and you'll even see the browser they were in. Above that, you're going to see the success, because I was auditing both successes and failures. And then if we look up on the server, you're going to see some information in the shadow log about this. You will see the failure that was shadowed from and to. If we right click on that and do a view, you're going to see that full text of that email with the header information, including the content. So even though that wasn't sent by AOL, it was shadowed and pushed up to our server. These logs are very easy to sort and filter. You can come in, you can create a filter that would let you sort by specific channels. You can sort by user, process, even file size if you're in the shadow log. So it lets you save these as well. It makes it very simple to control that. You can then right click on the shadow log viewer and choose the save settings, and that would let you export the file out as a CSV quite simply, and then bring it into any tool such as Excel or anything else that you want to use to manipulate that data or possibly graph it. When you come down to our reports, we have some built-in reports that will let you look at your data a number of different ways in the enterprise server logs. This would be like allowed, denied requests per channel, top active computers, top active users. You can even see the DeviceLock service by versions and versions by computer to help you with upgrading the product. When you run these, they come out, you can have them created as HTML files. You can have them come out as PDFs as well. So let's find one here. Versus denied requests per channel is a good one. In here you'll see we can show you the number of allows and failures, as well as a graph. This is against all of the information. You could also do this specific to a user or a machine. Set it. The same type of thing can be done with the search server. If we expand out the search server and go to our search page, you can search for a specific piece of information, click search, and it's going to bring that back in the log here. So you can see anywhere that exists in the log, as well as the associated shadow file.